Hello. So this is definitely a bit of a last-minute live stream. I usually try to announce them almost 24 hours in advance. I just ended up having a bit of more time today than I expected, so I figured I would use the opportunity to actually add a new feature to Incus just before releasing Incus 0.2 tomorrow. And that feature is NVMe support. So it actually came from Christian Branner, who was one of the other maintainers on Incus, a long time contributor and maintainer on the Linux Containers project, and also one of the VFS maintainers in the Linux kernel. And as part of his work and development environment, one thing he had to test recently was NVMe support, and he obviously uses Incus for his virtual machines. And so I had to poke around a bit using RAR-QEMU to actually pass in an NVMe drive. Thinking some more about it, there's no real reason why Incus wouldn't support NVMe. There's a lot of other device types and things in QEMU that we don't really want to support, mostly for security reasons. We're not a big fan of virtualizing real hardware, for example, like simulating real hardware, because there's easily a bunch of issues with that kind of logic. That's why Incus has been using virtio devices whenever possible, because those are very, very limited as far as logic in the hypervisor itself, and effectively just passes things through using shared memory. Now, that's why we're using virtio-scsi, but there are some other types that would be in theory safe to add. The other thing is we don't want to needlessly have to add extra controllers to the virtual machines, because then it's PCIe devices that are always there, drivers that always load, and that's not ideal. But NVMe doesn't have that concern because it's just PCIe devices. So we already have a PCIe bus, so adding NVMe is pretty straightforward. And the other thing is we should be able to add plain SCSI, so not virtio-scsi, but effectively SATA through a virtual Intel SATA controller. We don't really love that controller because, again, it's like fake real hardware. Like it's QEMU faking an Intel SATA controller. That's not ideal, but there's no way for us to remove it because it's part of the basic Q35 VM definition. So given the controller is there, we should probably also allow attaching to that. So that's what I want to look at today. I've not actually done any prep work on that, so I'm hoping things kind of work the way I expect them to. But yeah, the general idea is going to be look at the code base for where we currently attach things to the virtio-scsi controller, and just try to modify those code paths to attach to NVMe instead. And then if that works properly, then add a new config option to the disk devices that lets you pick what bus you want to use. So that's the general idea. Let's take a quick look. So I actually do have a terminal open somewhere. Yeah, there. So that's my local Incus running in debug mode. We can see I've got a bunch of things running. Let me see. Okay, so I've got that V1 device, a V1 VM here, and we can see it actually is passing tmp foo.img, that's allowed in AppArmor, and that's then attached as a drive, NVMe with a random serial. So if we go, that's what I just did to show Christian that this was working. And if we go inside the VM, look at the PCIe bus, that's where we see here a NVMe controller, and that then provides this device. So that's kind of what we want to do, but instead of doing it manually like this, effectively do it properly through Incus itself. So the next thing that's a bit odd is most of the VM definitions we do through a text file. So that's easy to go and inspect. So in this case, it would be this file. See, what did I mess up? Oh, right. It's actually var log incus. Okay, so that's the config file we generate for QEMU. and it's got a bunch of devices attached to it. But one thing it doesn't have, so it's got the SCSI controller here, that's the virtio-scsi controller, but it doesn't actually have any of the drives themselves. And the reason for that is that we use QMP instead, so the QEMU control protocol effectively, to add those devices. So we can't just go and like poke at a config file or modify that config file to do what we want. That's just plain not gonna work. Instead, we need to go and modify the QMP calls to not use that that controller I showed earlier, which is here, SCSI controller. So not use this particular controller, so not use QEMU_SCSI, but instead use NVMe. So that does show us kind of what we need to look for now. So if we go in here, we want to look at anywhere we're using QEMU_SCSI, because that's effectively what the controller is. So we can see there's a file here that's just test around the config generation. We don't need that. This is the one that actually generates the config file that we just looked at. That's also not the one we want. But then you've got the QEMU driver here, where there's a function. So I think it's like a device add type function, like a disk drive add. Yeah, add drive config. So that's the function that currently goes on to attach to QEMU_SCSI. So that's gonna need to change. And so instead of QEMU_SCSI, this is gonna have to go and do NVMe. Now, we can see here that there's an ID, there's a drive, there's a bunch of other stuff. The drive itself, we shouldn't need to mess with that. The drive config needs to exist either way, so we'll just leave it as it is. The bus that needs to change, and channel learn don't really apply in the NVMe case. So let's just go ahead and, for now, just go and hardcode things. So I think what we'll want is effectively do a base device and then yank out the bits that are specific to the backend, so those. So currently just do if false. Okay, why isn't it pasting the thing? I just copied, that's annoying. Okay. There. So if false, so I'm just gonna put that as dead code effectively. Jesus. Okay. So if false, we'll do those bits. So this is on the device. The bus in this case is that guy. And then this is the channel. And then lastly the run. So again, none of those really apply to NVMe, so that's fine. We'll just put them here. Eventually, this is gonna turn into a, is the device configured for virtio-scsi bus or SCSI bus or NVMe. For now, we'll just put that under false. And otherwise, so that's where things get more interesting. So the bus, I believe, should be NVMe. Let's just go look at the config here. So it shows drive. So the drive already exists, and then the device shows NVMe. So it could be that it's just a bus. Always a bit. It was a bit confusing exactly how things line up. My guess is that it would actually be the driver that needs to be NVMe. And so the bus would not actually be touched. Let's try that. So this chunk is effectively all under, all disabled and will be changed later. And in here is kind of what we need to change. So that becomes, if media disk would do else, if false, this thing. Okay. And so the default driver is gonna become NVMe. Let's do that for now and see how that works. So if we just look at the code change for now, oops, there's something wonky going on there. On what line is it? It's on it's on this guy. Oh yeah, there's a random white space. Okay, so just try to build that. Not happy, more than one character in 3734. It's just my single quotes making it very unhappy. Yeah, okay. Okay, let's just fix that. Okay, that should make it a bunch happier. There we go. So that just gives us QEMU running again. Now let's just restart the daemon and Incus, let's do launch of a new instance. So just call that v2 as a VM. And this failed. Failed adding device bus PCIe 0 does not support hot plugging. Okay. That's interesting. So we do need to effectively specify a bus. I just don't remember how that part works. Let's see. It's kind of funny because on the command line we don't have any of that problem, but the command line also does a lot of magic behind the scenes. So that's kind of what we're dealing with here. If I go back to looking at the config, so we can see here that we're adding a device and it's connected to a specific spot on the PCIe bus. So it's using QEMU PCIe 1 in this case. We do have a function that allows allocating arbitrary device on the PCIe bus. So I wonder if we need to do that. Just remember how that works, because we do something like that whenever we add a network device. So trying to remember how that works. So let's just look for bus in that file. Alright, there we go. Bus.allocate is the magic function. Now bus allocate, do we call it somewhere? I want to see what we do for hot plug of network devices, since that's going to be very similar to what we need to do here. Okay, so that's the main device setup. It's not what we want. Yeah, okay. Okay, so that's the extra slots we allocate for network and devices. Okay, just look at the config again here. So QEMU. It uses PCIe.0, which is, I think, exactly what this tried to use. PCIe 0 does not support hot plugging. Yeah, okay. How does that work? Okay, so we do have effectively spare PCIe devices. Yeah, here we can see them as QEMU PCIe 5, 6, 7, 8. Let's just try to use one of those and see what happens. The last one is actually used for something by the looks of it. So QEMU PCIe 7. Let's try to use that one and see what happens. So let me just get back to where we were. So NVME, and just do here device. So actually the bus section I already had put earlier. So QEMU PCIe 7. Let's try that. Obviously, not something that we could ship with because it's a bit hard coded and probably not a good idea to go and steal that particular device, but hopefully that will give us a better idea of what's going on. So let's see. I guess it created the VM, just didn't start it. Yeah. All right, so it did start fine with that. Okay, so that's interesting. Now the question is, can they all share a PCIe device? Because I would rather add kind of one PCIe device and then hang all of them off of that instead of having to dynamically allocate device. The concern there being that since storage is hot pluggable, we might have some issues if we've got too few of those slots effectively. I actually wonder if it's going to boot at all, because it's got its root disk on NVMe now. So not sure it's going to work. Okay. So we've got the BIOS splash screen, but that's about it. That's interesting. What's going on? Like, I never tried to actually put a root device as NVMe before, so this could be a problem. Let's just restart this thing and do the text console. That might show us more. Restart. I'm sorry. So it briefly showed boot devices, but then went blank. So not sure. Let's restart again and try to stop it in the firmware this time. Okay. Boot manager. So what do we see? Okay, so it does show QEMU NVMe controller, Incus root. So the root device does show up just fine. It might be more of a grub config or something similar that then doesn't work. Let's see if we can figure that out. Yeah, not really. Anyway, it doesn't really matter because, like, especially for the initial use case we care about for this device, it is to add additional disks as NVMe, not the root disk. In this case, it's just the root disk because that's all I have. So anyway, this is effectively a success. We've got NVMe running. Now the question is, can we make it without hardcoding stuff? That'd be better. So just stopping it. So the question is, can they kind of share a bus? So doing like a multi-function bus effectively. We go back to the config. We have a number of QEMU PCIe devices in there. So here we've got QEMU PCIe 0, for example, which is used for the balloon device, and also used for the random number generator. It's used for a few other things. So let's look at the PCIe device for the SCSI controller and try to use that. It is not multifunction, so I suspect we might have some issues with that. QEMU underscore PCIe 2, let's see. Okay, so start. Okay, so that did work. So that's interesting. Now, how do we handle that usually? Because I effectively would like to have a fixed bus that can be used for NVMe devices. That would be the best option. But how do we identify that? So I kind of want to look at the network devices again, because they are the closest thing. Okay. Admin dev config, cool. And how does it figure out what device to use? Configure queues. So there's a function called addNIC here that probably does what we want. What's M in that context? Sure. Okay, so addNIC is, okay, so that's actually a QMP monitor thing, okay. NetDev add, sure. So that does add the network device, but that also means part of the NetDev description should point to a particular device there. So we see QEMU NetDev ID type Vita post. Okay, well, so in this case this is just passing an existing Vita device. We also have these NetDev. Okay, so it's the QEMU dev. So is it the NetDev that's attached to something else? So QEMU NetDev. No, because it's there. Where is the bus for this thing? Okay, so it is actually passed bus name as part of its call. Well, that explains it. Dev config. Okay, so this one gets QEMU bus here, and this function is device attached NIC. Okay, so that's the live modification one. So connect to QMP. PCIe and PCI require a root port device name to hot plug the NIC into. Yep. And so we pass PCIe dev ID. Okay. That definitely works for network devices. I just wonder for our storage case, like they seem to be fine with sharing, effectively sharing a slot. So it would probably be better if they were just dangling all on the same one. That would be simpler. The question being, can we actually do that? So if we look at bus allocate here, so we allocate different groups. The problem, so effectively the issue we've got here is we need to support hot plug, and we don't know. Effectively, don't know. We can't store anything in memory. The struct that has all of those devices and all that stuff is just loaded from the database every time we try to modify an instance inside of Incus. Like an API request comes, Incus loads the struct back from the database. This means that I can't easily show up that QEMU PCIe 7 is the one we want. Instead, we kind of need to go and look at the current QEMU config. So that leaves us with one main option really. I think we might do it exactly like the next, which is we use that reserved set of PCIe devices for any kind of hot plug for NVMe, and for normal disk add at startup, we just generate them on demand using bus.allocate. That means that the call to it means we need to pre-generate the right number of PCIe entries, which is a bit frustrating. Actually, it is kind of weird. I wonder why let me just check something. Come on. QEMU PCIe. Okay, we've got this one hard-coded there. I wonder if we can't just shove them all on QEMU PCIe 0, because we know that this one always exists and is already used by a bunch of other devices. that would be simpler. Just like we use virtio-scsi here. Let's see what that does exactly. The other thing I'd like to do, if possible, is only do the NVMe trick on additional disks. That would mean that we can then start that VM and actually look at stuff. That would be better. So let's see. Is there anything in here that tells me whether it's the root device or not? Because that would be good to know. That could have changed a lot since it was first written, so it's getting a bit tricky to wanted to remember a lot of it effectively. Intro features, drive conf. Okay, so we can actually look at that target path. So that's one way to know, which means that instead of my further down, I think instead of my if false, I can be slightly more careful now. Okay. So what we'll do for now is if the target path is slash, so if that's the root device, then we go straight with normal SCSI, and if not, then we do NVMe. And we'll do the exact same trick here. Media disk, and then we'll just do actually we'll do this slightly differently. So if the target path is slash, then SCSI hard disk. If it's not, then let's go with NVMe. Okay. So the idea here is that the VM, when I restart it now, it should go on virtio-scsi, it should boot properly, and then I can add some additional disks to it, and those should show up as NVMe. That will make it a bit easier to test. So let's see. Restart an Incus, and then, okay. So let's start v2. Okay, it's starting up. Go. And this time it booted properly. Okay, so we must be on virtio-scsi, that's good. Let's install PCI util so we can see what's going on with the PCI bus. Okay, now let's go ahead and create a couple of disks. Oh, never mind. I need to actually do disk 1 size. Let's do 10 gig and type is block. Create. Oops. All right. I'm dealing with a remote XD cluster instead of with my local Incus, so it's a bit of a problem. Okay, let's create 3 disks. So disk 1, disk 2, disk 3, each 10 gig. And let's start with something that most likely will blow up, but might as well. Pull default, source disk 1. Okay, that did not blow up, which is slightly surprising. Okay. It did not blow up, but also didn't really do anything. Okay. So we don't have an NVMe drive that showed up. I don't remember if there's any need to do a rescan. I mean, it should have showed up as a PCIe event. Let me just Google that real quick. Is there some way to do that? We can force a rescan of the PCIe bus. Let's try that. No, nothing showed up. Yeah. To be fair, I was not really expecting that one to work. Just checking it didn't show up on the wrong bus. No. Okay. So it's gonna restart the VM. This time it should start back up with the drive added as NVMe from the start. Assuming it does start. Okay, looks like it is. Okay, we're back on. Okay, that's odd now. This time it should have showed up because we did get that mostly working the last time around. Okay, let's turn off the VM. Look at the code again, make sure I didn't mess anything up. So ID, drive, and serial, they're left mostly untouched. If the drive is slashed, then we go ahead and attach it to the SCSI bus. Otherwise, we go PCIe, which is the NVMe. And then if media is a disk, we go NVMe. If it's slashed, then we go SCSI hard drive. So that looks correct. I think it's mostly, again, a PCIe bus weirdness going on. Let's see. I'll do the BJ console. And to just stop it in the firmware. I want to see if we get an NVMe drive at that stage. We do not. Never mind, we do it here. Okay, so that's interesting. It shows up just kinda. So I think it's probably my abusing of the shared PCIe bus that's causing some issues, maybe. Let's go and see that. So again, PCIe 0, so that was probably the issue. Let's just look at the config from earlier. So if I use one of the shared ones, so PCIe, let's do 7. Let's try that and see what happens. See if it actually shows up in Linux if we do that. QEMU PCIe 7, okay, let's rebuild. Because PCIe 7 is going to be completely unused, so it's fair to use that PCIe root port. Whereas PCIe 0 is already used by a couple of devices, so it might not have liked me adding a random NVMe drive to it. Okay, let's try that. Okay, so it started, and what do we have on PCIe? Yeah, non-volatile memory controller. So we do have the NVMe drive this time around. Okay. All right, so that's interesting. So yeah, it means we can't just shove it on the shared one. That would be a problem. Now what happens if I add more disks? So can really trying to see if a single PCIe root can be used by multiple NVMe drive. So I'm going to be adding the second disk. And let's see what happened. Okay, did not see any events. And we still only have a single NVMe device. Okay. Let's just do a rescan again. Video seems frozen. That's odd. Let me just check here. Can only see VS Code, not the shell. Okay, just load the YouTube video here, see what's happening. Okay, loading it here. It seems to be working just fine for me. So it's probably an issue with either YouTube or your system, because loading the stream in a new window works perfectly fine. All right, so we've got one NVMe drive again. Let's see what happens if we reboot now. The idea is to see whether after reboot we see both devices or if we just see one. So far, all the behavior would point to us only seeing one. And indeed, we only see one. Okay. It's just interesting that QEMU doesn't fail in any way whatsoever. It just doesn't. It just doesn't really do anything. There might be a way to do. It might just be a question of like not having specified an address or something or not, and it being able to actually do multiple devices, because let me try something. So from the config we saw earlier, QEMU PCIe 7, which is what I use right now, is a single function PCIe root port. PCIe 8 is a multifunction. So let's try that, see if that makes a difference. And I realized instead of poking around, I should probably go and read through the PCIe spec again, like I did back when I added VM support to LXD a long time ago. But this is a lot more fun, so. Reading those specs is not particularly fun usually. Okay, instance not running, it's good, let's run it. Okay. So question is, are we gonna get 0 NVMe device, 1 NVMe device, or 2 NVMe devices? Let's see. Dev NVMe, 1, just the 1. Okay. So that's usually where I go, the QEMU source code root, and let's go look for NVMe devices in there. So there's block NVMe, which is probably what we want. Okay. I suspect we should be able to add an NVMe controller and then add multiple devices on the one controller, which would show up as different QEMU nodes, effectively, NVMe nodes. Okay, so that's the code of the actual NVMe block device implementation in QEMU. I'm kind of just looking, but they usually have all of the parameters somewhere. The other thing that can be interesting to try is just to look at their tests. That does a pretty good job at covering all those options usually. So far I'm not seeing a whack ton of config options on this one. Yeah, so tests, I'm going to see tests, Q test, NVMe test. So there's some tests in there. PC device, there we go. Okay, it looks like the NVMe stuff, I'm gonna have to do some more poking. That's gonna be easier off stream than during the stream, I think. That being said, here we can see a bit of an example that's got an address set at 0x0. So I wonder if we should try to set an address, like a different address for different devices, if that would help somehow. That said, how do we do that? We could use the boot index, I guess, as that should be really unique. It's kind of just a shot in the dark at that point, but I just want to see if we can just have multiple devices show up in one shot. Otherwise, I'm going to have to go a bit more complex route and actually properly set up an NVMe controller, which is probably the better option anyways, but let's just try it that way. Oh, it's no, integer to ASCII, never mind. So that's integer, and we want to use this logic here. So that will actually set a different address. The question is that the addresses are not going to be sequential, so that might also cause some issues. Let's see. Anyway, if that doesn't work, what I'm going to be doing to still keep that live stream mostly interesting is going to be to shelve the NVMe side of things and just focus on the SCSI controller, because that should be a bit easier maybe. To just try and use the existing Intel SCSI controller that's present, try to get that working, because then that means I can work on putting the logic in place for the config key and showing how that works, and then I'll do NVMe afterwards effectively. So let's go, this is build, load that, and is it currently running? It is, so stop it. And start it back up and see what happens without a typo. Yeah, it's not happy. NVMe adder doesn't take value. Ooh, okay, what the hell happened here? Oh, right, I know. Never mind. Okay, so at least it shows that the config key does something. It's just that I did kept the I2A, which doesn't make sense because we actually do want the integer. There we go. So sometimes it's good to get QEMU errors just to figure that it actually did consider the config, because it's not always super clear that it does. So sometimes you're just like banging your head against the wall for hours and you just made a typo in the config key. So at least in this case, we know that's not the case. All right, and it did start. So given it did start, what's it gonna do? Mass storage. I don't see any NVM stuff here. Nope, no NVMe. Okay, all right. So let's just shelve the NVMe stuff for now, and instead let's try and get those to connect. So that means the driver is not gonna change. It's still gonna be SCSI HD for now. So just keep that here. Just put it like that. And here, what we'll need to do is still channel and LUN should still be there. It's just the bus is gonna change to another QEMU SCSI. I don't actually remember. I don't know what the bus name is by default for that one. So if we go and look, we can see here there's a SATA controller, 6 ports, AHCI. So that's the one we want to connect to. I don't know what it's named by default because this is part of the Q35 definition. I also don't remember how those definitions work in the code base of QEMU, but let's see. Maybe it's simple and we can just go look at its actual definition. So this one, maybe? Is that the one we want? Okay, so it does show here AHCI inside the device for Q35, one AHCI controller is built in. Okay. It shows it's an ICH9 AHCI that's being used. And it shows us being connected to an IDE bus, apparently. Which is interesting. Because this is a SATA controller, so it's showing up as IDE. It's kind of odd. Why does it do that? I know there's another definition, which was the PCIe host one. What does that have in there? Because like the first one indicated we should be able to do a bus IDE and just go with that, but That seems odd. If we look at Q35 specifically, there are some tests here. Let's see if they mention anything about the storage. Yeah, so it looks like we should be able to just use IDE.0, IDE.1, etc. So effectively going up the port numbers. I think this is going to be another issue, which is, do they support hot plug? I'm not sure that they do. And if we need to use them in sequence, that's going to be another issue of not having an easy way to keep that state, really. So let's just go see. virtio-scsi. So in theory, it's effectively you do ID.0. I suspect Chanel it's not gonna like it very much, because if it's actual fake IDE, that's not relevant. So let's remove that and see what happens. My guess is that this is gonna not work super well, because we're effectively trying to shove two disks into the same port, but maybe that's not how that particular controller works. So let's see. Okay, fit. Right, that makes sense. So instead of SCSI hard drive here, it's supposed to be ADHD, I guess. Let's try that. Still kind of surprised that the built-in controller does IDE, not SCSI, but not too sure what that's about. Okay, it does not support hot plugging. Right, so that is an issue. Well, this stream is going very well. That was kind of my fear. Like we effectively entirely rely on hot plugging within Incus, because we can actually do hot plug, hot remove of all of our drives at any point. And the fact that like we are dealing with a controller that can't do hot plug, that is going to be a bit of a problem. Let's see if there's an easy way to work around that. Not that I can easily find. Just did a tiny bit of Googling around Q35 hot plug into the built-in SATA controller, and it doesn't look promising. So again, let's scratch that one. I'm actually gonna go and modify the GitHub issue, because NVMe is gonna be possible. It just needs to fight a bit with the PCI layout, which is gonna need more concentration than I can have during a stream. But the built-in SCSI controller, that's not gonna happen, because that one just plain doesn't support hot plug, hot remove. So that needs to go away. There we go. Which means that pretty much nothing is working. So let me actually just go ahead and undo all changes I've got in that code base for now. There we go. And instead, we're going to be focusing on actually putting the config in place so that we can configure that thing. So the idea is to add that new config key, so the io.bus config key on the disk device, and then make sure that this gets set and that we can get to that property from within the disk hot plug function, and then I'll sort out the NVMe mess later on. So to do that, what we need to do is, where's that file now? It's disk.go in devices. Yeah, there we go. Okay, so that one should have all the config keys. Yep. And we want to add a new one here. So it's io.bus. Its validation is optional. Just looking for something here. Okay. Let me do validate is one off. Cool. So it is one off, and we want either virtio-scsi or we want NVMe. So that thing goes there. Now if we look for other places where io.cache is used, that should be a good indication of what we need. So we do need an API extension. So let's go and copy paste that. API extensions are effectively used by API clients to know whether a specific version of Incus supports a specific function. Not too sure what's going on with the git view here. I did not mean for that to show up, but anyways. So this is the new IO bus property to just devices which can be used to override the bus the disk is attached to. There. So that's for this file, and there's another one that should have the same update for as far as adding the extension, which is going to be in internal version, yeah, there, API. Okay, so that's all the API extensions that are supported. So if we look again for our cache one, it should be here, disk IO cache, we'll copy paste that onto the end, and that becomes disk IO bus. Okay, and next step is the documentation. So disk IO bus comes here. Default is virtio-scsi. Crap, that's gonna need the entire table reformatted. That's always fun. It's not required, only for VMs override the bus for the device, and this is virtio-scsi or NVMe. Okay, so this is just adding the config key. The next step is going to be to reformat the entire table, so that's always very much fun. Let's just go and commit those basic changes from us. So the first one is the new API extension, which I forgot the name of. There we go. So API extension is disk IO bus, and that includes its documentation entry, and that includes the API entry in the file. Okay. Then documentation. It's devices, so that's the doc. And then for the next part, it's going to be we need to realign the entire doc table, so that's going to become its own commit. This is, as I said, very fun. Let's see how many spaces I need. That many. And the documentation is actually being slowly moved to an auto-generated type documentation where you just leave comments in the code and then those best key tables are generated from that instead. This is gonna make this kind of operation so much easier because we won't have the issue of every time something changes a bit, we need to go and reformat the entire file. I'm also not super happy with having to reformat the file again, because it means that whenever something changes in LexD now, in that table, it's gonna just cause a whole bunch of mess I'm gonna have to manually deal with. But anyways. Reformat disk option table. Cool. So now the only change we have is the actual addition of io.bus. And again, if we go look at IO cache, it was added here to this config, which we've done, and then to the validation. So this is effectively just checking for keys that are not supported for containers. So we'll do the exact same thing here. So if we see IO, actually we should do IO we should do alphabetical order. So IO bus first, and it's just going to be IO bus configuration can be applied to containers. Okay, that's fine. Next up. So detect VM pool mount options. So this would then pass it as an option through the, where's that? Okay, so it's effectively passing in options through the device that we can then pick up on the driver side, or on the QEMU configuration side of things. So that should be okay. We can probably do the exact same thing. So we'll do allow the user to override the bus, and then just replace that with bus everywhere. The bus, here we go. Okay, so as far as the more mechanical type change, that's done. We've got all of those in place. Let's just go internal, yeah, internal server device disk and io.bus. Okay, let's see if things still build. Video quality isn't great, yeah. And thanks to YouTube, it streams at a high quality, but yeah, sometimes it does auto select crappy quality for some reason on the client side, and some other times it's also because I do the low latency stream, so that the comments I get to read them within 10-15 seconds instead of almost a minute delay, but then they reduce the quality because of that. Okay, so it complained about line 716, this file, whatever that is. So it's probably around here that there's something completely wrong is going on. Yeah, indeed. Okay, so if I don't do anything stupid, that should maybe build now. Okay. So again, I'll just effectively be putting all of the logic kind of in place and then do the hard-coded bus to validate that things behave. And I'll sort out the actual bus numbering and PCI hot plug rules and stuff after the stream, because that's going to take me a little while. So now we should have all the logic that passes that config key effectively. So if I go look at, not this, but go, I want driver QEMU, this one. Now that's where we should have the handling for the cache already, and we're going to be doing effectively the same trick to pick up that value. So let's look at what we were doing with the cache. Cache mode, RBD. Okay, so far nothing special, nothing special. Cache mode. Okay, there we go. So that's where we actually extract the cache. Check if the user has overridden the cache mode. So we'll do the exact same thing for the bus. check if the user has overridden the bus. Go to the options, look for bus equals, extract the bus from that. And here we go. Default bus should be virtio-scsi. And then we pick up whatever the user has set. Okay, so with that, we should be able to get the actual config as provided by the user. And that means that when we get to, where is that again? Down here. Now we can do if bus virtio-scsi, then do that. Bus NVMe. We don't need to do an else because the validation is already in place, so there's no case where that would be a problem. So device. Now, as we said, the channel and learn, those are specific to SCSI, so they should go here. Learn. Okay, so those two things can go away, and the bus obviously will also go away. So cumulative SCSI 0 here. Oops. Okay, and then here is gonna be the bus, which is QEMU PCIe, what we're using, 8, I think for this, well, 7 or 8, doesn't really matter. Let's use 7. And then that's where the driver changes. So if media is disk, and if, so basically what we're going to be doing is that if it's, actually, so there's specific logic here for ISO images, so they don't show up as a SCSI disk, SCSI hard drive, but they still show up as a SCSI CD-ROM. But with NVMe, there's no such distinction, so I think we're going to need to kind of put the whole thing into if bus is virtio. Not sure what that check is there. It's actually going to just look cleaner if it goes up. Let's just move it there. So in this case of SCSI, we do that, but in the case of NVMe, the driver is just always going to be NVMe. Okay, so in theory, that might be it. Again, it's using my hard-coded PCIe 7, which is not good. But that piece needs a bit more thought and handling. The easy trick I could do is repurpose the logic from the network devices to effectively use those hot plug 4 slots we have. But that then means that the NVMe drives and the network devices share a very limited number of PCIe devices. If I do go that path, I would probably actually add more or do 2 different chunks so that the network devices have their dedicated 4 and put another 4 for NVMe drives. Anyway, the thing has built. Let's restart it. And just look at the config we've got on that VM. It's got, so 2 disks we know it's not going to work with the current outcoded stuff, so we might as well remove it. We'll just remove disk 2. And then we start the VM. So at this stage, it should start with root and extra disk both on the virtio-scsi bus. If that works, then we can shut it down and change disk 1 to be NVMe and see if it shows up as NVMe. Okay, so the system is running, and if we look at the disk by ID, we've got 2 disks attached on the SCSI bus. So far so good. Incus device set v2 disk 1 IO bus NVMe. Oops, config. Okay, so it did accept the config, which is a good start. And it did start, so that's good. Now to see if it actually shows up as an NVMe device. Okay, boot it up. So again, let's do disk by ID. And this time we can see SCSI only has the root disk, and then NVMe, we've got NVMe 0 and 1, which is QEMU NVMe controller, Incus disk 1. So yeah, that works. And that's that. So it does have, we effectively have commits now for adding the API extension, adding documentation for the new config key, reformatting the documentation, actually passing through that config, so doing the validation and passing it all the way through, and then attaching to the NVMe device. So that functions. Again, the main issue right now is that hard-coded QEMU PCIe 7. That's obviously a very bad idea and needs to change. And as part of changing that, it should also then allow for multiple disks to be properly attached on the NVMe bus, which is currently not working. And it should also allow for hot plug and hot remove, which currently also I would not expect to work. And we can try it just for kicks, but I don't expect to have a good time with that. Let's see. So NVM, we see it. Incus config device remove v2 disk 1. Okay. So removal works. And interesting, there's nothing in dmessage, but it is gone. There's no more mention anywhere of that disk. But device add is probably not gonna work so well. So if we add it back, maybe we'll get lucky. Yeah, no, definitely nothing. Rescan? Nope. So yeah. Oh, that's interesting. Oh, okay. So it actually did work. I just added it back as SCSI because it doesn't mention what bus to attach to. So that's interesting. Let me just remove it again. So hot removed, and let's plug it back, but this time on NVMe. That's the part that I'm very, very suspicious of. No, works. Okay, so that's a very good sign. It actually shows that hot remove, hot plug, and everything works as expected. We can even hot remove one from one bus, hot plug into the other, works fine. So the main issue is actually figuring out what PCIe bus to use. And currently I'm using a hard-coded PCIe 7. Once I fix that, we should be in business. So that's very encouraging. I just need to find a way to handle that, possibly very similarly to how networking is done. So the main concern that I've got about the whole PCIe bus numbering things is for NVMe devices, it doesn't matter what slots they're plugged into, but for network devices it does. Network devices are effectively network devices are named based on where they are on the PCIe bus. So if you look, we've got ENP5 at 0, and that is because it is at address 5 on the PCIe bus. Now, if we start mixing both disk and network devices, we may not have the kind of guaranteed stable sequential IDs for the network devices, which would cause a whole bunch of problems. So that's why I'm probably leaning towards having a separate chunk of NVMe addresses for use in that case. I see that Christian is asking what the kernel version is. This is just stock 2204, so it's running the 515 kernel. If you want something more recent, we can do something more recent. But it shouldn't really change anything. I was gonna go get one of my kernels. So if I go, whoops, no, not spell Linux today. Come on, keyboard. There. So that's the config key. Oops. So this is Germany. We don't care about the source packages. We just want x64. There we go, and the GPG key for this guy. That will give us a 658 kernel. the one thing that's gonna need to happen is that VM ties turning off secure boot, otherwise it's not gonna be able to boot anymore, as the Zabli kernel is obviously not signed by the distribution. Okay, so let's turn that off. Config set v2 security secure boot false, and I don't know how to type secure boot today. There, and start v2, and we should see in a few seconds. Come on. Yeah. So VM is back up. We're now on 658. Just checking, we still have our SSD. It's there, and it's clear bit with remove. So we're gonna yank it out. There. We can add it back to the SCSI bus. Okay. Then yank it out, and then add it back to NVMe. And let's see what we get. Yeah, so that's a bit different now. So this would be, so that's the attachment. So I guess the removal didn't show up. This is when it got attached back, I guess. Then we see the PCIe change as it showed up on the PCIe bus. It's not super happy about the NVMe namespace for some reason, which is interesting. Let's see, what's the tool? There's a command line tool for NVMe stuff. Just don't remember what its name. NVMe CLI. There we go. There we go. So it does show serial number is actually the name of the device inside of QEMU. So Incus disk 1. It does show one namespace defined. The model is QEMU NVMe controller, and it shows the correct size and some kind of firmware revision. Anyway, this is gonna be it for this particular live stream. Hopefully you enjoyed me rambling about PCIe bus numbers and a bunch of the weirdness going on around there. But the bulk of the feature is effectively done and working. Now I just need to go and finish up trying to do the bus allocation and doing something that makes sense around that before I can send a pull request for it. So that's going to be an exciting new feature in Incus 0.2, which is due to be released tomorrow. Incus 0.2 also comes with all the changes that happen to LXD all the way to 5.19 and a bit after that. And also comes with an improved migration tool that can even handle clusters these days. So it's definitely going to be a much more polished version of Incus, and one that a bunch of people will be able to actually start upgrading to and start enjoying. And yeah, that's it for it. That's it for this one. If you've got any questions, feel free to leave them down in the comment section below, or you can go on the community forum. If you want to support my work, there are a few links to different platforms where you can do that. Yeah, tomorrow I'm going to be doing the 0.2 release. We'll also record a video that's going to go through all the stuff that's new, either because it got added to LXD and got inherited into Incus, or new features that were directly added to Incus, like this one. And while the release happens tomorrow, the actual announcement and all of the publishing the packages and all that stuff is most likely to happen on Monday, mostly because nobody likes surprise updates and stuff over the weekend. So that's it. Thanks a lot for watching, for your questions and interactions, and I'll see you in the next one. Bye.